Hello, everyone. In this chapter, we are going to address the human interactions with its environment. We're going to look at the impact of human activity on its environment. Now, as we go through this chapter, we are expected to reach or learn a number of things. One of the outcome is going to focus on the human population, how the human population grows in more developed countries and less developed countries, and also what do we call biotic potential and what do we call the carrying capacity for a given population. What do organisms need to thrive, and particularly the human population, right? What are the resources? Some of them are renewable, some of them are non-renewable, but what are these resources? What is the impact of human activity on the cycle of some compounds, including water, food, minerals? What is the impact on land use and energy use? What is the impact of human on biodiversity? What are the values of biodiversity? Whether these values are direct values or indirect values, we are going to also address ways that are not sustainable for our future, and also what are potential solutions to this unsustainable behaviors. What can we do to create a sustainable environment for our future? And finally, what do we call quality of life, right? At individual level and at the population/community level. So with that being said, let's first of all make a stop on the human population. Now, the human population has tremendously increased for the past centuries. Now, in 2023, the human population is estimated to be about 8.1 billion of people across the world. Now, if we consider the rate of growth of the human population, it is estimated that about 80 million of new individuals are added to the human population every year, which takes us to another aspect. That aspect is actually that of the growth rate. What is the growth rate? The growth rate is going to be determined by considering the number of births and the number of deaths each year. This is going to actually determine the growth rate in a population. As we consider the human population, that human population has grown exponentially since the Industrial Revolution. Why? Well, if you consider the pre-industrial revolution, we were living in scarcity, right? We didn't have a huge amount of resources. Actually, there was not as much resources in terms of food availability, for instance, as we do have today. We didn't have ways to maintain people in life longer than we are able to do it today. So the health conditions today are such that people can live a very long time. So added to that, we have a mortality rate among infants that is very considerably decreased, so that overall the human population is going to grow. That's why we actually see that exponential growth. So that actually when we consider the human species, we can consider that, well, we've reached a point where we can actually talk about biotic potential among humans. But what do we call biotic potential? A biotic potential for a given species is the maximum growth rate under ideal conditions. What we mean by ideal conditions, it's that there is no problem with the amount of food, so there is a sufficient amount of food to sustain whatever number of individuals that are in a given geographical area. There is no problem with space, right? We know that in terms of population growth, two major aspects limit a population is the resource that is available to sustain the life of the individuals and the space. Now, you're going to tell me that, well, Dr. Jean, the space is part of the resource. Yes, but earlier when I said resources, I'm thinking, for instance, food, I'm thinking water, I'm thinking really shelter, for instance. Well, actually, and then you have the space, right? You have the space where we live in, right? So usually in the environment, resources are limited. So it is not typical that a species is going to reach its biotic potential forever. That's not possible, right? They can reach a biotic potential for a certain amount of time, and then because of competition, that competition can be intraspecific, meaning between individuals in the same species. That competition can be interspecific between different species. Think, for instance, of you competing with deers and buffaloes for a space, right? That is completely possible, right? Because you plant your food and the buffalo needs to eat by grazing. Well, when you are converting the land the buffalo used to use for grazing, and you are going to now use that land for planting your crops, including, for instance, corn, well, or potatoes. That is basically a competition that, that is going to happen there. Anyway, let's move on. So I want you to know what growth rate is and what a biotic potential is. I want you to know these definitions. All right. The other definition that is very important to know is what we call the carrying capacity. So eventually, because each species will try to reach its biotic potential to obtain to produce as many offsprings as possible, because there is no problem with space, there is no problem with amount of food, so resources are abundant, right? Conditions are ideal, so the organisms are going to multiply in an optimal fashion. However, in a given geographical area, that geographical area can only have so much food, it can only have so much water, so much space for living. Well, in that geographical area, there is going to be a limit as to what number of individuals in a population can thrive in that space without some starting to die off because of lack of resources. So now we're going to address the carrying capacity. So carrying capacity is the leveling off of the growth of a population to a level that this environment can sustain indefinitely. So a population can grow exponentially in a given geographical area only for a certain time. That population eventually is going to reach a plateau and level off, right? This is what we call the carrying capacity. So when we consider the human population, some people think that, well, we've reached the carrying capacity of Earth. That's you know, I'm not sure exactly what is being taken into account to determine that, but some people argue that we already reached or passed the carrying capacity. Now, in all objectivity, if we had passed that carrying capacity, well, I would not maybe be here to have this conversation with you, right? So others argue that, maybe we're going to reach the carrying capacity of Earth when we reach about 50 to 100 billions of people, right? But, I'm not going to argue about this because obviously there is room for discussion as to, what is the population of human it would take to reach the carrying capacity of Earth. There are a lot of discussions and a lot of controversies, so I'm not going to get into that. I want you to remember the concept of carrying capacity. I want you to remember that. All right. So on this slide, we are showing the growth of the human population over time. So from 1750 to about 2250, we are estimating the growth of the human population. Now, we see that the human population in more developed countries and less developed countries the growth was relatively flat for a long time. Well, not flat. Growth was happening, but growth was not happening at an exponential level. So if you look at you look at the 1900 right here, so you see that there is a growth, but it is a modest growth, right? However, when you consider the 1950s, you see that the population actually is starting to grow exponentially. Well, while this is not very noticeable in more developed countries, in less developed countries, you have a complete explosion of the growth in the population, right? So you can see the growth of the population. Look at in 2007, if we look at the growth, we see actually an exponential growth of population in less developed countries. Now, when you compare less developed and developed countries, you can have the impression that the population in more developed countries did not grow significantly, but it did, right? It did. So I don't want you to have the impression that it did not grow. Yes, it did. And actually, as a matter of fact, if you consider a country like the United States, even though we consider that the growth rate has tremendously decreased, but the population in the United States is still growing, right? So anyway, so now going beyond 2024, right? So if we extrapolate as to how the human population is going to grow worldwide, well, we see that the population in more developed country will kind of reach a plateau, will start kind of going down. There are two possible, predictions. There is one prediction that says that, well, the population in more developed country will still kind of be growing, but it's going to reach a plateau, while another estimate says that, well, there is a possibility that it's actually going to go down by the year 2250, while the population in less developed country will actually keep growing tremendously and maybe reach a plateau, or that population can keep growing exponentially. It just depends. Now, the indications that we have as to 2024 it's that this population will actually keep growing. Okay. Now, all right. So comparing more developed countries and less developed countries. Now, in the more developed countries, we do see overall a low population increase, averaging about 0.1% population increase rate per year. In the US, that increase is about 0.899, right? 0. Almost 1, right? While the growth rate in less developed countries is going to be around 2.5%, which is considerably different compared to the more developed countries, right? And this is comparing what happened between the year 1960s and 1965. But when we look at the less developed countries collectively, there is a declining in the growth rate. Now, when we look at the increase in the growth rate in less developed countries, many of them actually are located in Africa and in Asia, in the Pacific, right? We have an increase in the population rate in these areas. So the world growth rate overall has slowed down, but the population will keep growing. Why? Because when we consider the demographics, there are more women than men in the world population. There are more women entering the age of reproductivity, right, than women that are leaving the age of reproductivity. So that overall, that global population, that world population will keep growing. So here we are comparing the pyramid of age or the age structure between more developed countries and less developed countries. Now, when you look at the more developed countries, we are going to see that the children, so individual in pre-reproductive age, is going to be, the population size is going to be very narrow compared to the less developed countries where the base is going to be very wide, right? The individuals in reproductive age in more developed countries overall are going to be more than the individuals in pre-reproductive age. If you consider, for instance, a country such as Japan, right? In Japan, you have that children are less numerous than people who are in a reproductive age, or even worse, a post-reproductive age. It's that dramatic in Japan, right? Now, the story is not the same in the United States. Okay, so when we look at the post-reproductive age, we have a narrow top, right? Which means that, well, you have less and less elderly people, right? But people live in age that is very old, right? So you have many people who live 80 plus years, right? Now, in less developed countries, again, the base is going to be extremely wide, which speaks to more children than adult in the population. And we can see that it's actually narrowing down as we go up. And life expectancy overall is relatively short, right? So you are going to have few people 80 plus, okay, compared to children 0.4 years old, which means that when you consider the population and the age structure in less developed countries, well, obviously, this population will grow and grow and grow even exponentially because you have a wide base, right? So progressively, these children here will replace the people in reproductive age in this area, right? And they are going to produce children causing the population to grow. While here, overall, the population size will tend to shrink over time. All right. So now we know that overall, the population worldwide is growing. However, the resources are limited. Now, what resources are we talking about here? There are two types of resources you want to keep in mind. One is the non-renewable resources. Two, it's the renewable resources. When we talk about non-renewable resources, we mean, for instance, the amount of land, okay? You cannot make it up, right? You have a certain amount of land, that's it, right? Fossil fuel, it's another non-renewable resource. You have so much oil, so much natural gas underground. And minerals, you have so much minerals, right? You have so much minerals available in the pool and so much mineral available in the reservoir, right? You have so much water available, even though, water can be cycled, right? But let me close that parenthesis. In terms of renewable resources, these resources actually technically can be renewed, such as water, right? But we are going to see that, well, the rate at which we use water can cause us to think of water almost as a non-renewable resource, right? But, I'm not going to stretch it that much to avoid any confusion here. So we have water as a renewable resource. You have plants, you have animals. But here is an interesting thing that I want you to remember. When you consider the growth of the human population, the use of non-renewable resources, and the use of renewable resources, guess what? We tend to use too much and putting in the environment more than the environment can itself handle. That leads us to situations that we call pollution. Okay? So pollution is going to be considered as one of the side effects of resource consumptions. And the more people we are, the more we consume, the more waste we produce, right? Now, it's not necessarily always in terms of waste, but it's even in terms of what we use. If you consider, for instance, an average middle class US citizen, right? An average US citizen, middle class, he's going to have a house, a car, and a yard, right? So they're going to have a yard and they want their yard to be green. So they're going to do whatever it takes to make that yard look green, right? And look very appealing, right? So they're going to use fertilizers. These fertilizers, while technically it's not waste, right? It's there to allow the proper growth of a lawn so it looks good. However, that fertilizer, we are going to use it in amount that the microorganisms and the small ecosystem where we are putting that fertilizer is not going to be sustainable. It's going to run off, go in streams, lakes, ponds, and cause pollution of water, right? You see where I'm going. All right. So land use, we've not been very wise as to how we are using our land. If you consider a country such as the United States, and you consider the coastline of the United States, whether you are on the East Coast or on the West Coast, well, along the coastline, people actually are clumping along the coastline. People are clumping along the coastline. And because they are clumping along the coastline, this is causing an erosion of beaches, causing a loss of habitat and a loss of wetland because people are are building everywhere, right? So what was at one point a wetland, well, guess what? Before you realize it, you're going to see a development there, right? Over time, that becomes a problem. How about, if we go more within the land? When we go more within the land, so away from the coastline, you are going to see more and more areas that are going to be semi-arid, okay? Or basically, we are going to see a desertification of land because of our practices, including overgrazing, right? So we are growing animals, right? And these animals need food, right? And the major food, it's going to be grass, right? So they are going to be grazing over that land, causing actually a desertification of the area. Now, I'm not even mentioning carbon dioxide and greenhouse gases, global warming, which is another story about, desertification. But let me close that parenthesis. So the removal of vegetation is tremendously impacting the area so that the desert is actually progressing, right? When you consider actually the change in the land, how the desert is expanding progressively to areas of desertification, almost in across all continent, right? We see loss of vegetation because of, logging, right? So we do see in tropical rainforest a major loss of the forest, right? And actually you have yearly a world meeting where they are actually discussing the fate of the forest in South America, in Africa, in the tropical areas, because let's face it, there is so much competition in terms of economy worldwide that no one wants to stay behind. And because no one wants to stay behind, if you consider a country like Gabon, which is my country of birth, right? Gabon, when we look at the country, 80% of the area of Gabon, it's rainforest. Now, initially, right? But as Gabon is in competition with other nations in the world, because no one wants to stay behind, guess what? Well, Gabon is tapping into its resource, which is wood, right? So they are doing logging like crazy, right? Now, obviously, they have other resources, including oil. Actually, they do have a bunch of it, but, let me not dive into that. But what we see here is that Gabon, which is one of the countries that actually is the lung of the earth, needs to preserve its forest. Yet, we are not being that wise, right? Because, people come from the United States, come from come from Asia, come from different continents to say, well, Gabon, you have so many diverse type of wood that we can use for so many different things. Can you sell it to us? Well, guess what? They're going to say, oh, yes, for what? For some dollars. Okay, well, not a problem. You can cut the tree. Okay? So that's exactly what happens. So we see here, right, how deforestation can actually lead to loss of habitat and loss of biodiversity. And actually, we don't talk enough about it, right? Loss of forest means loss of biodiversity. That is very important to remember. Now, how about the water? The water we use is actually very valuable for the environment, very valuable for us, but we are just using too much of it, right? If you consider how we use water, most of the fresh water is going to be used to water our crops, right? For irrigation. 70% of fresh water is used for irrigation. Okay? Well, let me rephrase this. 70% of water that is used in irrigation is fresh water. There we go. Now, when you consider the use of water in the industry, well, it's about half what is used for irrigation. Now, when you come in our houses, the water you drink, the water you use to cook, the water you use to wash your clothes, your dishes, all of that, it's about half what the industry is using. But altogether, we are using a bunch of water. Because we are using a bunch of water, well, guess what? Where do we get that water from? Well, we get it from surface, okay? Streams, rivers, lakes, the sea, right? But also, we get it from underground. The aquifers, strats, right? We are pumping water from the ground. That doesn't go without consequences. And what are some of the consequences? Well, the consequences, well, you see right here, right? There is a drop in the land, okay? And that drop in the land is thought to be caused by a pocket that was created by pumping too much air. By pumping water from the ground. By pumping water from the ground, well, what was at one time a layer filled of water is going to be empty. And obviously, land is going to sink, right? So we have a sinkhole here, okay, that may be caused by the depletion of water underground. So while we are pumping water, we have to be wise as to how we are doing things. Now, because of, we are also aware of our consequences on the water we use. So we're like, what can we do to actually conserve water? Well, some of the thing that is done is to actually, rather than planting plants that actually require a huge amount of water, we can, for instance, plant these plants that actually preserve water, that need so little water that we don't need to water them, right? We don't need to water them. So they are going to preserve water, yet we're still going to have our nice green environment. So the type of plants we are planting for, our pleasure can allow us to save water. 2, how we are watering plants, right? Rather than using an irrigation system that is open to the atmosphere, well, we can use an irrigation system that actually uses drips, right? Like this garden hoses here, right? They release drips of water just as needed so that water is not wasted. How about water reclamation? Right? We have a wastewater treatment plant facility here. That wastewater treatment plant facility allows us to actually clean the water we get from our household. You know, when you flush your water, when you wash your dishes, when you shower, different things you do at home, that water goes somewhere in the city. And in the city, that water is going to go in a wastewater treatment plant facility. There, the water is going to be clean of all impurity. So you're going to have cleaned water and sewage sludge, right? Once you separate them, the water that is deemed clean is now going to go back to the environment by releasing that water in streams, rivers, or go back in our houses for reuse.